Hello everyone, let's continue to study the fourth chapter, subgrade design. Now I will introduce the last part, subgrade drainage. In this part, I will introduce the following contents: water source and effects, surface drainage system, subsurface drainage system, and general requirements. In highway engineering, two sources of water are primarily concerned. The first one is rain, snow, adjacent lake or rivers, while the other one is the groundwater, which include purchased water, unconfounded aquifer, spring, etc. Effects of those two sources of water may include washing away the soil, which leads to slope erosion or slope protection damage, leading to geological disasters such as landslide and collapse, etc., making the road body less resistant to traffic. For example, weaken the load-bearing capacity, which induces settlement by groundwater. In the frozen soil area, because of the temperature and the water, frozen soil deformation is the mainly damage of the highway. Drainage for these two sources of water are referred to as the surface drainage and the subsurface drainage. Let's look at the surface drainage system. The main facility of surface drainage include following types, such as side ditches, interception ditches, etc. Next, I will introduce each surface drainage measure. First, the side ditches. The side ditches are arranged outside the foot of the cutting slope or fill slope, which are popularly used to collect and discharge the side slope water. According to the shape of section cross, the side ditches are divided into trapezoidal, rectangle, U-shape, streamlined side ditch, etc. Second, interception ditches. Interception ditches are used to catch and lead away from the surface water coming from a higher area before it reaches the road, or to direct water to where it can safely cross the road. Interception ditches usually have a trapezoidal cross-section, and the excavated material should always be deposited on the downhill side of the ditch. Third, mature drain. A mature drain is also called an offshoot drain, which is an open drain designed to divert runoff from a drain or road shoulder away from a road. Others: hydraulic drop and chute. Hydraulic drop and chute are special forms of a drainage system which are applied in abrupt slope whose longitudinal slope is greater than 10% and water hand height difference is greater than 1 meter. Hydraulic drop is the structure through which the water from the upstream channel may flow and fall into the downstream channel over a drop. Chute refers to the channel on a steep slope and is also known as the suspended ditch. This type of drainage facility is usually used for leading pavement water into the fill subgrade side ditches, or leading the water from the interception ditches into side ditches. We also use in-water siphon and aqueduct to convey water across the subgrade. Inverted siphons are used to convert water across a natural depression under a road or under a canal. Aqueduct is a channel that is constructed to convert water from one location to another location over the road. In areas with arid climates where drainage is difficult, we use evaporation ponds. Evaporation pond is a pond with very large surface areas that are designed to efficiently evaporate water by sunlight and exposure to the ambient temperature. Then let's look at the subsurface drainage system. The facilities of subsurface drainage include seepage ditches, underdrains, and seepage wells. Followed is a brief introduction. The first is seepage ditch. A seepage ditch collects underground water to the ditch by way of seepage and eliminates the water to a designated location through channels. Its function is reducing or intercepting groundwater. Seepage ditch is suitable for groundwater buried shallow and layers without fixed aquifers. Seepage ditch is divided into rock-fill seepage ditch, pipe seepage ditch, and tunnel seepage ditch, as shown in the pictures. The second is underdrain. An underdrain is a drainage system installed under a road or road ditch to collect and transport subsurface water. These buried conduits come into a variety of shapes and sizes and are usually wrapped in textile fabric, which allows water to enter the conduits while keeping sediments out. The third is seepage well. A seepage well is a vertical direction underground drainage facility going through the impermeable layer to discharge the underground water from the top of the embankment to deeper water carried, so that the upper underground water can be reduced. According to the National Highway Drainage Design Specification, the following factors should be considered in the design of highway drainage facilities. First of all, investigation or survey should be performed on hydrology, weather, topography, highway classes, and functional requirements in the overall design of the highway drainage system. Secondly, drainage design should be consistent with the main structural and natural environmental conditions. Of course, different drainage facilities should also be consistent with each other. A third, road drainage should not be integrated into farmland irrigation, and water from roads is not allowed to drain into farmland or irrigation facilities. Fourthly, the drainage design should be environment friendly and minimizing effects of populations on natural environments. Finally, the drainage system should be economic, easy to construct, convenient to maintain, or durable. Okay, let's summarize this section. We have introduced the following concerns: water source and effects, surface drainage system, subsurface drainage system, and general requirements of subgrade drainage design. Thank you for your attention. See you next time.